Hello everyone. Welcome to another video. It's a new week. Please make sure to check your grade book. If you see a missing assignment and you completed it, make sure you're also submitting it into Schoology. And I have updated the grade book, so you should see your current grade as to what you have currently in the class. So this particular activity is called Recursion Machine, and the warm-up asks us to press play to see the machine create a sequence. And part B says, how would you describe what the machine is doing? So let's take a look. Beautiful. So we see that these numbers are alternating between negative and positive. That's a big clue. We have a negative, a positive, a negative, a positive. Usually when that's happening, we're multiplying or dividing by a negative number. I would also say that the number, not looking at the sign, whether it's positive or negative, the number is growing, right? 5, 50, 500, 5,000. So it would seem like we have some multiplication going on here. So you want to just pick two numbers that feel good in your brain to see, like to go from -5 to 50. What could we multiply by? And that's going to be a -10. And 50 times -10 is -500. -500 times -10 is 5,000. So we see this is a constant ratio, which can be multiplication or division of -10. And you can share that with the class when you're ready. And then push ahead to slide 2. So this says introducing recursive definitions. The machine creates a sequence using a first term and a rule. Together, a first term and a rule can make a recursive definition. If we know where we're starting and we know what the rule is doing, we can find all the terms in the sequence. So it says to change the first term and the rule to create some new recursive definitions. So just to show you how this works, we could make our first term 2, and we could say it's going to be a constant difference, and we're going to add 8 each time. And then we could make it. So it starts with 2, plus 8 is 10, plus 8 is 18, plus 8 is 26, plus 8 is 34. So it can make us a sequence based on where we're starting and what the rule is. It wants us to create as many sequences as you can that include the number 12. So a great way to do that is to put the number 12 at the start. Let's do this one as a ratio, and I'm going to do times 1/2. Remember, multiplying by 1/2 is the same as dividing by 2. Multiplication and division are inverses, they're twisted, they flow together. So 12 times 1/2, or divided by 2 is 6, divided by 2 is 3, divided by 2 is 1.5, and then divided by 2 is 0.75. So here's a sequence. That's a nice, easy way you can start with 12, and you can get 12 in the sequence. Some other things we can do is if we start with the number 4, what would we have to add to get to 12? Well, 4 plus 8 is 12. So 4 plus 8 is 12, plus 8 is 20, plus 8 is 28, and plus 8 is 36. So we can see that's another way we can make a sequence using the number 12. So please keep exploring with this, see how the sequences are made, see how many number 12 sequences or sequences with the number 12 that you can get. And when you feel good, push ahead to slide 3. Okay, so sequence challenge number 1 says, in this sequence, the first term is 1600. Create a rule that will produce this sequence below. So we're going from 1600 to 400, and then 400 to 100. So it's definitely not subtraction, right? Because we would subtract 1200 to get to 400, and then we only subtract 300 to get to 100. So subtraction is not the same. So it has to be constant ratio. How do we get from 1600 to 400? Remember, to figure this out, we can look backwards. We can also look at easier options on our board. For example, maybe you see 125 and you know, well, that's just divided by 4. You could also open up your calculator and say, what is, to work backwards, what is 400 divided by 1600? And we get 1/4. So that affirms our theory that we're dividing by 4, multiplying by 1/4 is the same as dividing by 4, and we can check it. 1600 divided by 4 is 400. 400 divided by 4 is 100, and we see the pattern continues like so. So we are doing a constant ratio of 1/4, which is dividing by 4 or multiplying by 1/4. Check your work. See that it matches up beautifully. Perfect. And when you're all set, you can push ahead to slide 4. Sequence challenge number 2. In this sequence, the first term is 3. Create a rule that will make the fourth term 24. So we see here that our first term is 3, and we just want this one to be 24. So we could think about this a couple ways. We could think about it using addition. We see that the number is growing, so we would add a number here. I'm just going to put x because we don't know what that number is to get to that term. We'd add a number here to get to our third term, and then we'd add it one more time to get to our fourth term. So if we start at 3, and then we add 1, 2, 3 x's, we end up at 24. So we can make ourselves a little equation. Now, to solve this equation, we want to get x alone. So we can subtract 3 on both sides. 3 minus 3 is 0. And then we have 3x equals 21. Divide both sides by 3. And we get x equals 7. Which means each time, if we add 7, we should get to 24. Let's check it out. 3 plus 7 is 10, plus 7 is 17, plus 7 is 24. Beautiful. So we added 7 each time to get from one term to the next, and we used a little equation here to figure that out. We could see if this works for a constant ratio as well. If that was the case, instead of adding the same number, we would multiply x each time to get to 24. So 3, and then we're going to times it by, oh, wait, hold on. Oops, that's not my eraser tool. We're starting with 3, we're multiplying 3 more x's to get to that 24 value. So we're starting with our 3, and then we're multiplying it by 1x, 2x, 3 x's to get 24. X times x times x, this is x cubed equals 24. Divide both sides by 3 to get x cubed equals 8. And then when we take the cube root of both sides, we would get x equals 2. So it also works for doubling. Multiply it by 2 would get us 6, and then 12, and then 24. So we could do this with the difference or with the ratio. Beautiful. Any questions, or if you need exponent or solving equation help, we're going to keep doing that throughout the year, but you can always reach out to me if you want to find a time to meet to look at this and review this more deeply in a small group. I'm always happy to do that. Let us go to slide 5. So it says create a recursive definition for a sequence that makes the second term 25 and the fourth term 1. Okay, so if we're at 25 here and 1 here. So let's think about a constant difference first. The numbers are getting smaller, so we're definitely subtracting. So 25 minus some x and then minus another x would get us to 1. So we're at 25 minus x equals 1. 2 of these minus x's is a negative 2x. We would then want to get rid of the 25, move it to the other side. So we'll subtract both sides by 25. And we bring down this negative 2x equals 1 minus 25 is a negative 24. Then divide both sides by negative 2 to get x equals 12. So we are subtracting 12 each time. But we don't know what our first minus 12. We don't know what our first term is, so we want to work backwards by adding 12. So if we were at 25 plus 12, that's 37. So we just did the opposite addition to work ourselves backwards. Let's try this out, see if it worked. 37 minus 12 is 25. 25 minus 12 is 13. 13 minus 12 is 1. And 1 minus 12 is negative 11. Beautiful. Brilliant. So we can definitely do that using constant difference. To think about it with constant ratio, instead of subtracting x each time, we would be multiplying by some x, 2 x's to get to 1. So we start with 25, multiply it by our constant ratio, multiply it by another constant ratio, and then we get to 1. So this is 25x squared equals 1. Divide both sides by 25 to get x alone, and we get x squared equals 1 over 25. Last step to get x alone is to take the square root of both sides, and that gets us x equals, just to show you in the calculator, the square root of 1 over 25 is 0.2 or 1/5. So we're multiplying by 0.2, which is 1/5. So this is constant ratio of 0.2. And we're not starting with 37 anymore. To go backwards, we would want to do 25 divided by 0.2, which is 125. To get our first term, and check your work. 125 times 0.2 is 25, and then 5. And multiplying by 0.2 is the same as dividing by 5. So we see there's a way that our constant ratio could work here. Beautiful. I'm going to pause the video here, so come back for part 2. Hopefully you're feeling good. I know this is a lot of math, but y'all are rocking it. So check out part 2 when you're ready.